The next part we need to install is the lower shrouds. And when you get to these parts, you've got to talk about the thermostats because they're mounted to the lower shrouds. Now the thermostats are the number one most overlooked, maligned, and misunderstood part on the Corvair engine. Everyone thinks they know how they work, and almost no one actually understands how they work. Many folks completely leave them off with the mistaken idea that they want maximum cooling all the time. So no need for thermostats. This is a huge mistake. Yes, your engine will run with no thermostats installed, but would you take the thermostat off your Ford, your Toyota? No, of course not. If you're building a dune buggy, a race car, or a swamp buggy, go ahead and leave them off. But if you're building a street car and you really want to run thermostats. Why do cars, any cars, run thermostats? Well, the engineers want to maintain the engine at the ideal temperature, not too hot and even not too cold. Why is too cold bad? Too cold means lower miles per gallon and more engine wear. If you're not running thermostats, your engine is actually too cold most of the time. I know that seems impossible, but I have real-world data that shows it. People mistakenly think that the stats start out closed, then fully expand in a few minutes, and the damper doors run open all the time. This is just not true. In the real world, the bellows expand to 75 to 80% of stroke. And this makes sense. The engineers want the engine to maintain a constant temperature, and, excuse me, cat, and that extra 20-25% is for when you stress the engine in mountains, really hot days, and heavy, hard driving. Here's the stock Chevy stat. It's not the best design. It has several flaws. Now you could find used ones, and Clark's Corvair offers new ones, but they have the same problems. My stat design has solved these problems. So what are the problems with the original design? The original bellows is stainless steel. Mine is phosphor bronze. It all comes down to thermal cycles. Any metal will eventually split and fail if you thermal cycle it enough. Stainless steel has a relatively low cycle count, while phosphor bronze is the king of thermal cycling. It can handle many more cycles before failure than stainless. The construction method. If you look at how this is actually made, it's a stack of concave discs and they're welded together. That means there's a weld seam along every outside edge and every inside edge. Now, if you actually add up all of these inches, it ends up a huge number. It's 103 inches of stainless steel weld. That's over 8 feet of welded joint. And you can have a leak anywhere along that. My design, this bellows, is actually one piece. This started out as a flat piece of metal. They pressed it into like a can shape, and then they put it on another machine that hydraulically squeezes it and puts this profile on it. So this is one piece. This is like 46 pieces. On the original, plus you have, now that you've welded it all together, you still have the tops and bottoms are soldered on, and then the fittings are soldered on. So you have a total of 13 inches of solder joint. On mine, because the top is actually built in, you've only got 7.5 inches of solder joint. Makes a big difference. On the original design, when this bellows is cold, it's fully compressed, as you can see. Now what that means is, inside here, the bellows are all touching each other and all fully compressed. So you heat this up, it expands, you're going down the road, and you got air from the engine blowing over it. And let's face it, the air's not clean. There's dirt, there's grime, and even road salt gets in there. And then it gets between these bellows, and then it cools off, and it crushes all that stuff inside there. You restart the engine, there's a little bit of vibration. You got engine vibration, road vibration, and those bellows rub against each other. It can make holes. My design has an internal post. And what that does, this all goes together like this. When it's compressed, it's compressed together, but it's not hard on the stops. So there's more forgiveness here. It's not a tight joint between the bellows. The bellows will not press together as hard. That makes a big difference in longevity of the stat. Now, and finally, of course, if you go out and you find a used one of these, you got no warranty. If you buy one from Clark's, their warranty is 6 months. My warranty, 2 years. Think about that. My warranty is 4 times longer. So now, looking at how these things are installed, first you have a rod that goes on this end, has a special fitting and a special little clip. Just fits right in through there like that. Now when you pull this closed, you'll notice it's not really closed. You don't actually want it tight. You want, that's about a 1/4 inch gap. You want that. And then the bellows itself, they're a little tricky to get installed. You have to feed in the long end first and then get the short end, and it fits in here. Now the back is actually a slotted hole. And what that means is once you get the stat set, it doesn't rotate. That's good. So what you do, you pull the door closed, look at this, and now you see that's how much you need to thread the rod in to the stat to get it in proper position. So we'll thread that in, get it in proper position, and then put a nut on the back, tighten it all down, and you're ready to install it on the car, on the engine.